Hello Science 30s. In this video we're going to be talking about beta radiation. Please watch the alpha radiation video first. In alpha radiation you'll remember that why it happens is that the electrical forces in the nucleus overpower the strong nuclear forces that are there. And some alpha radiation or alpha particles are released and you get a different product. With beta radiation, it's very similar. It's just that the particle is very different. And the particle in this case is going to be, if we take a look down here, right here. So there's your beta particle, which is essentially an electron. So if we remember what these numbers mean, one electron, remember that, one electron has a mass of 0. So this is a mass of 0 up here. This number down here refers to the number of protons. And because an electron is negatively charged, we would actually consider this to be -1. And so that's beta. That's basically beta particle. We're going to jump right into an example right now, and I'll show you how to go ahead and do this with an example. Okay, so carbon-14 is a radioactive isotope that emits beta radiation. Carbon-14 is found in the atmosphere and eventually finds its way into living systems. Once a plant or animal dies, the amount of carbon-14 remaining in the tissue can be used to estimate the number of years that have passed since the organism's time of death. This is done by using the half-life of carbon-14. To get a clearer picture of human history, archaeologists use carbon-14 dating to estimate the age of ancient remains like teeth or bone fragments. Use this information to write a balanced nuclear equation for the beta decay of carbon-14. Okay, so first of all, carbon-14, we've already gone over how to do the nuclear notation of that. That's going to be carbon-14 with the number of protons, which is equal to 6. Now, the other thing that we're going to have to do here is we're going to have to then put our arrow, and we know they tell us right here that it's beta decay. As soon as you see, guys, that whether it's giving you any information there, alpha, beta, gamma, you need to go to your data booklet and remind yourself what those particles look like. So beta decay will lead to a beta particle, which means this will lead to an electron being released. And some other product. At this point, we don't know. There's no information in here that tells us which element it is that it decays into. So once again, we're going to have to figure that out. So again, we get our notation here. We have our A, our Z, and our X. And then we're going to try and figure out which element this is. Remember that these three are connected, and these three are connected. And so we are going to have 14 is going to equal 0 plus A. And we are going to have 6, which is equal to -1 plus Z. So A in this case then is going to equal 14 minus 0, which is 14. So that is going to be the mass number that we're dealing with of this element. And then the Z here is going to equal 6 minus -1. Well, 6 minus a negative is obviously the same thing as adding a positive, and so that would be 7. And so we then have nitrogen is going to be the element that is element number 7. So the 7 goes down here, the 14 goes up here. So now put this all together into our final nuclear notation, and we are going to land up with carbon-14 is going to decay into an electron plus nitrogen-14. And there we go. There is our final answer. That is the nuclear formula or nuclear equation for the beta decay of carbon-14.